Firstly, you can see the low pressure and high pressure circuits. The visualization here represents the low pressure and high pressure sides and shows how the refrigerant circulates inside the system. This diagram illustrates the gas and liquid stages of the refrigerant, circulating in the direction indicated by the arrows on the visualization. The air ducting scheme displays all flaps arranged in the correct order, as found in a real vehicle. For example, valve V71 controls the airflow flap, and valve V68 controls the temperature flap. You can also see the air distribution to the front footwell outlet, defrost outlet, and dashboard outlet. Next, you can see the control panel, located after the brightness or sun intensity sensor. There are two interactive screens. One screen shows the refrigerant temperature at the inlet and outlet. The second screen is a voltmeter that displays selected parameters of specific components. For example, if the voltmeter is set to G114, which is the control motor potentiometer for the airflow flap, you can change the potentiometer position and observe the voltage variation during operation. All parameters can also be measured using the external contact points integrated into the diagram. Next, there is the fuse box. The fuses correspond to those shown in the wiring diagram. The diagnostic OBD2 connector is located here. Additional terminals are available for connecting an external battery. Lastly, you can see the complete electrical diagram with a legend that marks and labels all components. The diagram includes jumpers that can be used to simulate faults or to take measurements using a multimeter or oscilloscope. The air ducting flow system diagram visualization represents a real OEM air ducting system, which is mounted below the control panel. Next, there is an electric motor that simulates the engine used to drive the air conditioning compressor. Further, you can see the cooling radiator with a ventilator. Here is the control panel. There is an auto mode. When you select the desired temperature, the system automatically adjusts the air heating to maintain the set interior temperature. The econ mode takes air from outside the vehicle and uses it to ventilate the cabin. In this mode, the air conditioning compressor is deactivated. The front window defrost function automatically adjusts the flaps to direct maximum airflow and speed toward the windshield. Air can enter the ducting system from the outside, or if recirculation is needed, it can be taken from inside the vehicle. This is regulated by the V71 flap. By pressing the recirculation button on the control panel, we can visually observe the flap moving to the required position. In this state, it takes air from inside the vehicle. Now, if we turn off recirculation, the flap repositions to draw air from the outside. Next, we can change the airflow speed by increasing or decreasing it. Additionally, we can select the target airflow direction, for example, to the upper vents or to the footwell. At the same time, we can adjust the air ducting temperature. The temperature is displayed in Fahrenheit and in Celsius for the European market. For controlling and analyzing how the air ducting, circulation, and flaps are working, there are LED indicators. If I turn on air recirculation, we can observe changes by looking at LED indicator V71. It turns red, then starts changing position, and begins blinking. When it completes its movement and reaches the final position, it stops glowing. Now let's turn off air recirculation. The flap starts moving in the opposite direction from before. The LED glows blue, starts blinking before completing the movement, and stops glowing after the flap closes. If we press another airflow position, such as defrost, we can observe the V70 flap position movement indicated by the LED. Electronic sensors are checking and monitoring the flap positions to ensure accurate alignment for correct operation. We can also observe how the flaps move on the real air ducting system. Let's change the airflow position. It is clearly visible on the green motor how the electric motor moves to the required position. The moving flaps are also clearly visible from the side. To change the airflow temperature, we observe the pink motor. When we adjust the temperature, the V68 flap regulates how much air is directed into the heat exchanger to reach the desired air temperature. The required temperature is achieved by mixing heated air with fresh cold air. If maximum heat is needed, the air flows only through the heat exchanger. If only cold air is needed, the V68 flap closes completely to prevent heated air from mixing.